So yeah, I'd like to introduce, my name is Bruce. I'd like to introduce Marcus Birkenkrahe. I know I slaughtered a little bit, but trying to get a little bit of German there. So yeah, he's going to be talking about teaching data science. And I'm personally interested in this because I've taught data science and I think it's going to be fun. So I'll hand it over to you. Go ahead and share your screen.
Thank you very much. Bruce, of course, we've just spent 15 minutes with you trying to properly pronounce my name. I just recommend to everyone online not to do that, please. This is not the complete title of my talk or of the paper that comes with the conference. The complete title is something along the lines of teaching data science in a synchronous online classroom at a business school. And not just any data science, but introductory data science. And what I've prepared today, really, well, first of all, I want to say a few words about myself, just very little, really, what I'm about, where I come from. And then I'm going to dive into the talk itself. So I'm originally a physicist. In fact, as it turns out, just like you, Bruce, from what I understand, I was one of the original developers of the World Wide Web as a physicist at CERN and DESY in the 1990s. So that's quite a long time ago. Then I became an oil executive for Shell, worked for Accenture and an executive coach. I'm also a psychotherapist in a number of disciplines and an author. And for the last, 15 years, I've been, almost actually 13 years, I've been a researcher and lecturer at the Berlin School of Economics and Law. That's this school here. And as we speak, I am in transition to a new position in Arkansas in the US at Lyon College. So what is this about, this introductory course on data science? I'm going to talk a little bit about why data science, then talk a little bit about the goals, give you some numbers, talk about an essential part of this entire endeavor, which is the use of tools and platforms, give a short introduction on the feedback that I received on the course, and reflect a little on the issues and on my learnings. And please, Bruce asked earlier, you can feel free to interrupt me anytime. If you have a question, put them in the chat. I cannot at the moment see the chat. I don't know why, but maybe you can alert me to it if that's necessary. There's also a pre-recorded version of an earlier form of this talk, which Bruce can put in the chat, maybe kindly as a URL. So what's the rationale for this course? Well, first of all, students requested it. I work at a business school, so data science is an interdisciplinary subject, and students became aware that it's an important area and that their usual training, introductory statistics, economics, marketing, and so on, marketing psychology, brand psychology, obviously always has aspects of data science, but there was no formal course so far at our school anyway. And from what I know, there are relatively few schools that have provided such a program, certainly at the undergraduate level. There's also a lot of available job openings, as you must be aware. There is, and this is fairly new over the last year and a half, there has been what I would call a statistics surge due to the pandemic. So an unfortunate reason, but a very clear signal that people understand that to know data, to understand data, to be able to visualize them, to be able to understand visualizations, question scientists, question politicians is an important issue, and therefore the interest has really increased quite a bit. There's also a very complex skill profile, and of course the entrance to any sort of teaching endeavor is to think about, well, what is it that I can teach? What should I be transporting in my course? And this is a typical, I don't want to go in on the details, just take in the big picture that there are three different areas in data science: the domain knowledge, so knowing things about actual things, areas of knowledge, then programming and technology, and then mathematics and statistics. And there are different views, but no matter how you cut it, this is a complicated pie. There are a lot of different individual things to get to know. It is also a mix of soft and hard skills, which makes it quite attractive for the classroom, because you can have periods of discussing results with technical periods. So, no matter how you cut it, it's worth thinking about how to do this. You don't just go in like maybe you do with a programming language and just go and take a book and teach it. Yeah? So it's a difficult thing. What were the goals of this course? And I'm going to give you a little more background as we go along. The goals, as far as the students were concerned, was to help them to embark on something that's often in the literature called data-driven storytelling. So to be able to make sense of the data and communicate that in a meaningful way, especially using visualizations. And the cue for that is that I also wanted to teach them programming skills. In particular, I put this in quotes because it isn't really programming and creating programs. It's more interactive programming using a language called R, which some of you may have heard or know already. And R is a statistical programming language. What this is in the picture you see a cartoon by one of the more prominent data scientists in the world. In fact, I think she's called head of decision intelligence, so decision-making intelligence at Google, Cassie Kozyrkov, and she has tried to highlight some of the issues around data-driven storytelling in this cartoon. So these were the main goals. However, there was a hidden agenda, and the hidden agenda includes to improve the data literacy, something I mentioned a moment ago. It included to teach the students computational thinking, so the ability to deduce things from the areas, and also, and this is a kind of I wouldn't call it a hobby horse, that sounds too harmless, of mine, but to support science in business. I don't know if you've taught at a business school or any really interdisciplinary subject. Very often people make a difference between, well, this is science, you have to put in citations, references, you have to work systematically, but this is the real stuff, this is engineering, business, producing things, talking to people. And in data science, as the word says, a craft aspects, anything related to data, come together very nicely with the scientific aspects. So this was a third issue. And also, as you're probably aware, not only since the pandemic, but science at large is, one could say, in some quarters anyway, under attack. So, it doesn't matter which area you mention, you probably have heard as scientists of the replication crisis, which is one of the main issues of fraud in science and so on. And so there seemed to be an issue about supporting science. So no matter how you cut it, there was a big interest. And before I go to the actual course itself, I would like to just give you some idea about the technical level, the level of sophistication and content that the students were embarking on in this course. And these results are adapted from recent textbooks and tutorials. They were demonstrated in class. So what you see now is the result that we were working towards in class using the R programming language. All of these were also shown on video, but this is already part of my toolbox, which I will explain in a moment. So as I said, if you have any questions, because I'm going too fast through some of the slides, and I will increase my tempo as I go along, because I have quite a lot of visuals that I would like to show, then please let me know via the chat. I cannot see the chat right now, but I hope this is not a problem. So here's an example. This is a scatter plot. And as an aside, the scatter plot shows the US gun murders in 2010. It's a relatively complicated plot. It's got an x-axis, a y-axis, got logarithmic transformations involved, as you can see on both scales in the axis. It has a legend. The legend uses color in order to qualify categorical variables, in this case, the region. So there's a lot going on in this plot, and it's not a plot that you would, in fact, knowing any programming language, you would be able to produce in seconds. You would have to think about it a little bit. Now, as an aside, as I look at this plot, I want to share something that I realized only after, and I forgot to put it on the slides. In data science, a little bit like in maybe journalism, you look at books, and in the books, very often you have negative data displayed. For example, the textbook this comes from is one of the big textbooks by Irizarry, a Harvard professor. He uses the gun murders, he uses this, that, and the other. And most of the data provided are negative, which in a follow-up course, I decided to change the negative data by positive data. For example, instead of a data set US gun murders, you can also look and learn as much from a data set called baby names. It's a very popular data set. Now, I can see you as you sit in front of the computer. When I say, now I'm going to talk and we're going to work on US gun murders, you have one emotion. If I say we're going to work on a data set of baby names, you have another emotion. And very likely, most of you are going to smile, internally at least, as I already say the name baby names, you know. So this is something I realized, that the students could be more motivated with positive data. Sometimes hard to come by, but actually the data sets exist. Here's another one. Now, this is a rather positive one. It's a heat map plot. Very easy to create, actually, with a certain pattern, very relevant for the pandemic, because what it shows is the change of measles cases across all of the states in the United States before on the left and after the vaccination. So in the mid 1960s, there was a large vaccination program in the US. And as you can see, without me having to explain very much, how the story continues post-vaccination on the right-hand side. So this is the kind of picture we obviously would like for COVID as well. And then a last penultimate one here, this is so-called stacked densities map using a particular data set, Gapminder, also very well known, which contains poverty and development data from all around the world. Not as easy, this kind of plot, to interpret, to read, but what you see at the top of the plot is the actual line. It's actually only one single line, more or less, broken up across different lines to create this rather complex plot. So this is what the students were working towards. And the very last one, which I begin to show in the beginning of the course to motivate them, this is an animation of the very same data, namely the Gapminder data, showing life expectancy versus GDP per capita as it evolves from the 1960s to the year 2010. Also a positive plot. So I showed the students these kind of results, and of course they got excited, because I said at the end of the course you'll be able to do this stuff. So now, what were the numbers of this course? The course had 85 participants, and I should say, maybe at the beginning, there had never been such a course at our school. It's a relatively large business school. I forgot to mention that. We have 11,000 students. That is one of the largest business schools in Germany, if not the largest. You know, well over 700 lecturers and well over 900 courses every term. And 85 participants agreed to join this course as part of the so-called extracurricular program. So I wanted to pilot this in the extracurricular program because I wanted to test it for different populations at the school, not just one program, but across the entire school. And that worked out really well, as you will see in a moment. So I had 55% female students, 45% male students, and I had really bachelor students, I think, were about 60%, 40% were master students. The exact numbers you will find in my paper. The course contained 16 different assignments, long assignments, roughly through every week of the course using the data camp portal. It contained 11 long quizzes using Kahoot quiz portal. There were 11 live meetings in the webinar software called Big Blue Button, which some of you may know. It's an equivalent to Zoom, Microsoft Teams, Google Meet, and so on, except it has breakout rooms, and it also allows to create recordings and very easily to create on-the-fly polls. And this is sort of the big time eater in this course. I created a total of 115 videos in this course. A mixture, most of them were screencasts, where I simply show how to do certain things, but some of them were also full-fledged lecture videos. These videos went from about 2 minutes length to 15 minutes length, but 115 is a large number for such a relatively short course of only about 40 hours live sessions. And the total number of platforms here were 8. So there were 8 different platforms, including GitHub, Moodle, DataCamp, Kahoot, YouTube, our own media server, site called Ideas Board, and Big Blue Button. In fact, I have highlighted them here. This is from the paper. I don't want to go into details here, but you can see this is a very large tool set. Now, some of you may also work with more than one tool, and Bruce told me earlier that he teaches data science. He showed some things, he works with cameras, he works with a platform, he may have a learning management system. Most of you may have that too. Very few of you will use this many tools in your course. And this is not much for my courses. I usually use up to 20 different tools because I'm kind of a tool fanatic. Now, the interesting thing is that in this course, the students did not complain. So in this digital teaching world, it seems like there is a greater willingness, let's say, to embrace large number of digital tools. This is a noticeable difference from my classroom experience, where whenever I tried to add another digital tool, there was an outcry. So in direct comparison with the classroom world, I would say digital tools are not so popular, but if you already teach in a digital world, it's different. So I want to go relatively quickly through some of these highlights just to give you a glimpse. And if you have in the questions, I can see the time is ticking, we can go and look at some of these in more detail if you like. So Github repository and Wiki was an important one because all the lectures, the lecture text and code was available on GitHub. Now that's one of the world's largest developers platform. It also includes an additional concept called version control, which is very important in software development. And I also added a personal dimension by writing a blog-like wiki for the students. I'm going to show you how it looks like. So this is a page from the, I hope you can see that. You don't need to look at the detail. This is how it looks like. It's very minimal. You see the code at the bottom page and the lectures. This is a view on one of my wiki posts. So instead of swamping the students with email, what I decided to do is, like, every once in a while when I felt like it, I would write a wiki post with some additional observations and thoughts. A second really central tool for the entire course was Moodle. It included a topical layout with images, content links rather than file uploads. So I was linking to a cloud repository and not uploading things into Moodle. It included integrated data science feeds. So some of the major weekly or daily feeds where people could read about data science were included in the Moodle start page. It included about one message per week. I'm going to show you an example, and many FAQs, many frequently asked questions. So here's a view of the top of the page. And as you can see, the headline of the course is "Love is the answer." So not data is the answer, but love is the answer. Students like that. And then you see a link to a forum and to the classroom. This is a look at the topical section. So behind every one of these rectangles hidden is a section of the course, which included the videos, lectures, screenshots, and so on and so on. So as you can see, I like to work with mixed media. This is the FAQ. By now, about half a year later, it's grown about 50% in size, includes a number of frequently asked questions for the course. I didn't only use Kahoot, I also used the Moodle quiz format. This is the Moodle quiz format. It has the advantage on the upper left side of the page, you see the question. This is already an answered question. Below that in yellow, you see the feedback that the students can get. And on the right-hand side, you see some navigation. So this is a very nice format in Moodle to also do open book exams, for example. And here you see an example for a weekly message. Again, a picture, some content, and so on. I was trying to send the students not too many messages because everybody does that. They had only digital teachers in that semester. So the third platform was DataCamp assignments. I'm going to run through this a little bit quickly. DataCamp is almost an industry training standard. It's a platform where students can look at little lectures and then do a lot of practice exercises. And it's worth about €300 a year. That's more than $320 a year. And we get free academic access for all our courses, for all our students. And they can also do hundreds of additional courses. They can collect certificates. They can put these certificates in their resumes or on their LinkedIn site and so on. This is the completion tracking site. So I had the different assignments and I could see the percentage of people who had completed them and who had not completed them. There's a leaderboard. So there's a lot of learning analytics information in DataCamp. This is an example for one of the exercises in the course, not a totally uncomplicated exercise where you have to manipulate a graph in order to answer a question, in this case, a dot plot. Here's another exercise. On the left-hand side, you see the exercise and the explanation text. On the right-hand side at the top, you see a program, and at the bottom, you see the console where you see the results. So it's a very nice condensed setup, which those of you who are from the craft will recognize this as a typical notebook setup. Okay, then I had Kahoot quizzes. Kahoot quizzes included weekly challenges. So whenever I would give a lecture, immediately afterwards, I would send them a quiz of between 10 and 25 questions quickly to answer in Kahoot. This is how the quizzes looked like. So there's, again, a picture, then multiple choice questions, in this case, quite technical questions. There is a poll. You could create polls in Kahoot. I have to say that I probably would not use Kahoot anymore because the participation and the feedback from the students said that it is a little bit too playful, and they preferred this type of setup. It looks more serious. I didn't really probe that. I didn't go into it in detail, but I thought it was an interesting remark, and I responded to it by going away from Kahoot. And each Kahoot quiz would also have a feedback video playlist. So this is how you get to 115 videos. Now, videos, I recorded the entire lecture before the session because it was the first time I taught the course. It turned out the students preferred the YouTube playlists because, as you can probably notice, I'm speaking relatively fast, but not really very fast for a native speaker. And nevertheless, the students like to listen to my lectures at 1.5 to 2 times the speed. So I sound like a crazed monkey when you do that, but apparently that's what the students do. They go through these lectures and play it at twice the speed. And as you can see here in the videos, most of these videos are online screencasts where I do something on the keyboard. I had an interactive timetable, and now we're almost done with the tools, with a lot of links to materials and activities. And that's the tool section. So what about the feedback for the course? You know, the students, as you know, are a little bit like shy deer, especially in the online situation. I don't know if that's your experience too. Anonymous feedback is very popular, but not anonymous feedback is a little hard to come by because, as I said, the students are shy. Now here's, I did 2 rounds of feedback. At the beginning, I asked them just simple 1 question. What did you like? What didn't you like? And they gave me some answers. And at the end, I used a survey from our school, which is very massive and has like 30 different questions. So basically, the result is that the students like the online didactic concept. So data science is a go for online teaching. We knew that already. They loved the course recordings. They loved the data camp assignments. They didn't like the fact that the student group was quite inhomogeneous, which is, however, for interdisciplinary topics quite typical. They didn't like the fact that I had too much material. That's probably something you are going to say too after this talk. And one person didn't like that there was so much effort for only 1 credit point because it was an extracurricular activity. This is a view at the feedback after the course. I don't want to bore you with individual statements. You find them in my paper, but on the left side is good. The left side is the maximum positive value. So basically, according to this line, the students loved the course. Here's a sample feedback, which of course I'm going to read to you because it sounds great. It says the professor is amazing. I'm the professor. So according to this, at least, I'm amazing. And I'm also very organized. So the students liked it. Overall achievements, I'm almost done. There were some public goals, which I put out before I started the course, and some private goals. Most of the public goals were okay. What didn't work out was the projects. So I'm going to make some changes around that. What didn't work out was my return on investment. I put far too much time and effort into it, which I will have to live off for the next decade or so. So the outlook is I would like to a little more interactivity, something along the lines of, I'm just going to open this in another thing and show you. This is something Schumpeterian waves. So this is interactive because the students can open these individual things. It's done with a tool called H5P, which is very great. I love it. And the students can work through this map in their own time. So something like that. I would like final exams sourced from quizzes. I'd like agile projects in particular. That's very important. I'd like to use Moodle quizzes instead of Kahoot. And this is for the experts. I like base R instead of the tidyverse, but that will be a longer conversation. Little reflection in the last minutes. For me, online works. The deprivation, the sensomotoric deprivation is totally bearable, I find. The students generally need much more time to do things online, and I need more sleep. And that's it. Thank you very much.
Great. So anybody have any questions? Feel free to put them in chat or put them in the Q&A section.
Yeah, sorry, I rushed a little bit through this, but I came in under the under the bar.
Under the time.
Yeah,
so I got one question, or seeing if people are typing a question or not. Was there any social learning aspect in here where they had to work as groups, like on data sets?
Oh yeah, good. Thank you so much. Yeah, I mean, not in that course. I suggested to them to do projects, but that didn't work out. In the follow-up course, because it didn't work out as a voluntary activity. However, the students were quite overwhelmed, I think, in the first pandemic semester. Now I do agile projects, which includes social learning. So they work together in project on data sets, have to create an exploratory data analysis in EDA, and that works really well. They love that, and it works very well at a distance as well. It includes a lot of coaching, so I meet with them on a weekly basis. I mean, for those who don't know, the agile project management technology, Scrum, may ring a bell. So I work with them in a Scrum way. So they have feedback sessions, sprint reviews every 3 or 4 weeks. And in that way, they slowly shuffle towards a very significant result, which, these students are, most of the students that I teach now are in their second term. So they are, I think in the American lingo is sophomores or freshmen even, first or second term. So they are very, very inexperienced. They have no domain knowledge whatsoever. They know very little of anything, and the results they turn in are quite amazing. Yeah, and I partly attribute the social learning aspect to that you mentioned. It's a good question. Thank you.
Great. What's one takeaway that anybody could apply to any online learning? Not just the teaching data science.
That's a good question. Well, I think that, and I hear this from the students a lot, that to have a much greater, much more sophisticated, let's say, I know that's a fear word, but a much more sophisticated knowledge and view of digital tools is really necessary. I mean, I hear the students' feedback from my course was not so much because of me or because of the data science, but because of the how I played with the different tools. So the right tool for the right purpose, but a large number of tools. And they really appreciated that. As opposed to somebody who just puts himself or herself in front of a camera and reads off a lecture text. And then once in a while does a poll. That's not really, the point is not that it's not state of the art. The point is the opposite way. Playing with tools and using tools in the right way really gets the students going and helps them through the slog of sensomotoric deprivation, that they're not with me in the same room. They can't, see me, talk to me, see each other. And you can bring in tools in order to at least bridge that. Not replace it. I don't think the classroom is replaceable, but bridge it to some extent.
Okay. Great. Thank you so much for the presentation. To look at any other questions,
Thank you, Bruce.
It was an awesome presentation. And again, the recording will be available on this website, the Learning Ideas Conference website later on.